this video we will discuss how to solve partial fractions. So here in this example, we are asked to express this expression in partial fractions. So there are a few variations of questions on partial fractions. So first one is if the denominator has linear factors. So in the example here, we have got ax plus b and cx plus d as the denominator. You can express partial fractions as a over ax plus b plus b over cx plus d. The second variation is if the denominator has repeated factors. So example is ax plus b and cx plus d square. So for cases like this, you will have to express the partial fractions as a over ax plus b plus b over cx plus d plus c over cx plus d bracket square. And the third variation of partial fractions is when you have quadratic factors that cannot be factorized. So example is if you have denominator with ax plus b and x squared plus c, and then you have to express it as a over ax plus b plus bx plus c over x squared plus c. So the very first step of solving partial fractions is to ensure that the fraction is a proper fraction. That means the degree of the numerator must be less than the degree of the denominator. If the numerator has a degree that is bigger than the denominator, we have to use long division method to make it to become a proper fraction. So in this question, numerator has a degree of 3 and denominator also has a degree of 3. Therefore, we need to do a long division to make it become a proper fraction. So let's divide 3x cubed plus 6x minus 8 by x cubed plus 2x, which is the denominator. And this will give us 3x cubed plus 6x if we multiply by 3. And if minus off, we get a 0 here. And if we bring down minus 8, that will be our remainder. So we can rewrite the expression as 3 minus 8 over x bracket x squared plus 2. And the next step is simply, we note that this is a case of quadratic factors that cannot be factorized. So we'll let it be equals to a over x plus bx plus c over x squared plus 2. And multiply both sides by x and x squared plus 2, we get 8 equal a x squared plus 2 plus x bx plus c. So now if we compare the coefficient of x squared, we get 2a equals to 8. Therefore, a is equal to 4. If we compare the coefficient of x 0, we get c equals to 0. And Similarly, if we compare the coefficient of x squared, we get a plus b equals 0, therefore b is equal to minus 4. Therefore, the partial fractions is 3 minus 4 over x plus 4 over x squared plus 2.